Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanif Fiddin Muhammad Rahim. If metric is number 24005180 today, I will be presenting about the experiment that I have been doing during this semester. There are five experiments that I will be presenting today. First, M2, which is rigidity of modulus wire by using Maxwell-Leader method. And SC1 oscilloscope as a voltmeter, MP1 photovoltaic cell, and one tension and kinetic fixture. First experiment M2, rigidity of modulus of wire by using Maxwell-Leader method. For the introduction, the rigidity modulus or shear modulus measures a material's resistance to deformation under shear stress, defined as the shear stress to strain ratio. In this experiment, the wire stiffness modulus is defined using the Maxwell-Leader method, which analyzed in the torsional oscillation of a needle. By verifying the moment of inertia using solid and hollow cylinders on the needle, the oscillation period is measured. The stiffness modulus is then calculated based on the relationship between the oscillation period, the system moment of inertia, and the wire rigidity. Next, the methodology of how this experiment is conducted. The wire's length and radius are measured using previous tools like ruler and micrometer screw gauge. The maximum needed is then suspended by the wire, allowing it to oscillate under torsional motion. Measurement of the oscillation period is solid cylinder placed inward and outward, reveal how the system moment of inertia change. And then we'll change the position of the hollow and solid cylinder. And here is the result that I get from the experiment. Next, for the result analysis. From the recorded oscillation periods T1 and T2, we apply formulas and derive from the principle of torsional oscillation to calculate the rigidity modulus. In the experiment, the wire's rigidity modulus was determined to be. Here is the rigidity modulus that we get. The experimental value compared to the actual rigidity modulus of aluminum show a 12% error. However, a significant uncertainty of 82% highlighted the need for enhanced precision in measurements. And conclusion for the experiment is the experiment demonstrated the viability of using the Maxwell-Leader method to determine the rigidity modulus of a wire and material of a wire. The result was reasonable accurate, but the high uncertainty 82% underscore the need for enhanced precision in measurement technique. The 12% percentage error suggests that despite imprecision, the material was sound and the result aligned with the actual value. Next, we move on to SC1, oscilloscope as a voltmeter. Introduction of the experiment is the experiment explore using a cathode ray oscilloscope CRO as a voltmeter for measuring both direct current and alternate current voltage. In a direct current circuit, the vertical deflection of the beam was used to establish the proportional relationship between voltage and displacement. For alternating current, the oscilloscope was used to analyze sinusoidal waveform, measuring peak to peak and RMS voltage. The experiment demonstrates the CRO's ability to measure dynamic signals while highlighting the importance of calibration and precision for accurate results. Next, how the experiment was handled. In part 1, the oscilloscope was used as a direct current voltmeter. The circuit was set up and the zero voltage level adjusted. By recording the vertical shift on the oscilloscope display and comparing it with a voltmeter reading, we confirm the relationship between voltage and vertical displacement. And in part 2, the CRO was used in a alternate current circuit. When connected, the oscilloscope displays sinusoidal waveform. From this, we measure the peak-to-peak voltage and calculate the root mean square RMS voltage. Here is the result that I get from the experiment in part 1. Here is in part 2. Next is the result analysis of the experiment. The amplitude gain factor K was determined in both parts of the experiment. For direct current, the value was approximately 0.69 with only a 4% error compared to the theoretical value of 1. For alternate current, however, K was 0.46 with a 54% error. This deviation highlighted the calibration issue and waveform measurement challenge. In conclusion, this experiment highlighted the versatility of the oscilloscope. It demonstrates its ability to measure direct current and alternate current voltage while reinforcing the importance of precision in scientific measurement. Improving the equipment and conducting multiple trials could reduce error significantly. Next, we move on to MP1, photovoltaic cell. Introduction of the experiment is this experiment investigates the performance of a selenium-based photovoltaic cell, focusing on how distant from a light source and the angle of light incident affect its efficiency, guided by the inverse square law. And here is the formula that we use, which describe how light intensity decreases with distance, and the cosine law, which predict maximum energy capture when light is perpendicular to the surface. The study stimulate a real-world variation in light intensity and direction. By the analyzing the relationship, it provides insight into the theoretical principle of photovoltaic performance and practical strategy for optimizing solar panel placement and orientation. Next, we move on to the methodology on how we conduct this experiment. There are two parts. In first part, which is in experiment A, the selenium cell was placed at verifying distance from a tungsten light source, which from 20 cm to 140 cm. At each position, the current was measured multiple times. Results show that the current decreased as the distance increased, confirming the inverse square law. And in experiment B, investigated the effect of light angle, starting with the cell perpendicular to the light angle were adjusted in increment of 10 and 5 degree up to 85 degree. At each angle, the current was recorded. Here is the result of the experiment. And here is the result for experiment. And for the result analysis, in experiment A, the graph of current against the inverse square of the distance demonstrates a strong linear relationship with a relative error of just 2.6%. In experiment B, the results show a direct relationship between current and the cosine of the angle. However, deviation at larger angles highlighted scattered light and edge effect, leading to a higher relative error of 13.41% for 10 increment and 42% for 5 increment. In conclusion, this experiment examined the behavior of photovoltaic cells under verifying distance and angles of incident light. In experiment A, the inverse square law was validated through deviation at larger distance, reveal limitation like radio sensitivity and interference. In experiment B, current decreased with cosine of the angle consistent with theory, but deviation at larger angle negated issue like scattered light relative error with 2.6% for distance and up to 42% for angle variation. Using LED light source and automation could improve accuracy and consistency. And for the last experiment, N1, tension and kinetic friction. And for the introduction of the experiment, tension is the force transmitted through ropes. Wires are string when they are pulled from the opposite end. When a string passes over a curved segment and is pulled uniformly, its tension varies depending on the angle of placement before motion. In figure 1 that we can see at the right, the tension at position N and the end differ due to the friction at position M. However, since the string is a constant motion, the total force acting at M equal to the total force acting at N. Next, we move on how we conduct the experiment. The experiment involved attaching a 1.5 kg block to a spring scale with a string and using an angle guide to measure the displacement angle. The spring scale was calibrated to zero and the block was moved uniformly to create tension opposed by friction. Measurements were taken at angle from 0 degree to 722 degree, with reading recorded 3 times per angle for accuracy. The tension was calculated using T equal to average reading multiple with the gravitational acceleration. A graph of ln T versus degree versus theta was plotted to determine the fraction coefficient mu, showing the relationship between tension angle. And here is the result of the experiment. Next, we move on to result analysis. To analyze the data, we transform the equation into a linear form. From the above equation, we get the below. For angle 0 degrees to 360 degrees, the friction coefficient mu was 0.0027 with a T naught at 17.63 Newton. From 360 degree to 720 degree, the mu slightly increased to 0.0034, while T naught rise to 21.12 Newton. In conclusion, The experiment confirmed the exponential decrease in tension with angle and accurately determined the friction coefficient mu under verifying condition. Result aligned with the theoretical prediction despite minor experimental variation, emphasizing the need for precise measurement. This finding provide a basis for further research into tension, friction dynamics, and mechanisms. That's all from me. Thank you.